Okay, in this video we're going to talk about even more derivatives. So just some more practice. The idea here is by doing lots and lots and lots and lots of derivatives here in these videos that you'll get better and better at using these formulas. Okay, so here are 10 problems for you to try. And what I'd like you to do is to maybe write these down. You'll pause the video here in a minute, write all these down, go work them, and come back, and then I'll go over each of these. So please do that now. Press pause. Okay, let's take a look at these. Now this first one's kind of interesting. It says, what is the nth derivative of x to the n? So of course the nth derivative of x to the n is you take the derivative of x to the n, which is n times x to the n minus 1, and then you take n minus 1 more derivatives. So then you take the next derivative, and this should say n minus 2 here. So you take another derivative, and then so you have n minus 1 times the n times x to the n minus 2. And then we have another derivative, and it'll be n times n minus 1 times n minus 2. And you keep doing this until you finally get down to the last time. It's just x to the first power, and the derivative is just 1. And so you end up taking n derivatives. First time you take a derivative, you get an n out front. The second time you get an n minus 1. The next time you get an n minus 2, I should say. And it just keeps going down like that all the way down to 1. And we have a shorthand notation for that. It's this little exclamation point here. We call this a factorial. So n factorial by definition is 1 times 2 times 3 all the way up to n, which is exactly what we get here. If we took the n plus 1 derivatives of x to the n, we would get 0 because n factorial is a constant. So the basic idea is every time you take a derivative, the power goes down 1 if it is a power function or a polynomial. Okay, so all the ones that I have written out here, I've just almost got their answers just kind of written down. I'm not showing a lot of steps. I'm doing a lot of the steps in my head. I'll be explaining those kind of as I go along. So the derivative of sine of sinh of x, you let u be sinh of x, and we have the derivative of sine u is cosine of u, so cosine of sinh of x, then times the derivative of the u. Derivative of sinh x is cos x. And that's done. The next one we're going to use the product rule. Think of 3 times e to the negative 0.8x as the first factor and sine of pi t as the second factor. So it's the first factor, 3 e to the negative 0.8t, times the derivative of the second factor. This is derivative of sine of u. Derivative of sine of u is minus, it's cosine of u, no minus. So cosine of pi t times the derivative of the u. Derivative of that pi t is a pi, which I put out here. Now, the second part, that's plus the second factor, sine of pi t, which is right here, times the derivative of the first part. So we're taking the derivative of 3 e to the negative 0.8t. So that's e to the u, or I guess I already used u, e to the w. E to the w derivative is e to the w, same thing, times the derivative of the w. The derivative of w is negative 0.8, and that's times this 3 out front. 3 times negative 0.8 is negative 2.4. And so we have that answer there. Alright, this next one's a little harder maybe. It's the derivative of sine of 5x to the x power. So that's like u to the x power. So this is a variable-based variable power. So we have to use the generalized power exponential rule. And it's like the exponential rule and the power rule added together. So first you do it like it's a power function. You bring the x down out front. You keep the same base, and you subtract 1 from the power. So that's x minus 1 for the power. And you multiply by the derivative of that base. So the derivative of sine of 5x is cosine of 5x times the derivative of 5x, which is where the 5 comes from out front. Plus, we treat it as if it were an exponential function. We have the same function we started with, sine of 5x to the x power, times the natural log of the base, and then times the derivative of the power. The derivative of x is just 1. So there's the final answer. Or we could factor out a little bit. They both have a sine of 5x, and let's factor out the smallest power we have. So it's sine of 5x to the x minus 1 power. When we divide each term by that, this cancels out completely here, leaving me 5 times x times cosine of 5x. This time, I get a log of sine of 5x here, and when I divide the sine of 5x to the x divided by sine of 5x to the x minus 1, I just get sine of 5x to the first power. And so I'd probably leave it like that for the final answer. Next, the derivative of sinh of log of x. Let u be log of x, natural logarithm of x. Derivative of sinh u is cos u, so that's cos of log of x. And then we want to multiply by the derivative of the log x. Derivative of log x is 1 over x. And we have to make sure that the x is positive, but that's implied by this natural log of x here. Actually, let me also point out that that the original function could have been simplified, and this one can as well. Let me show you a different way to write that. Cos of log of x is e to the power log of x cos is a plus here, and plus e to the power minus log x, and that's over 2. So I can put that down here with the x. And then the nice reason why that's kind of nice to work with is some of this simplifies here. So e to the log of x is just x. And this is e to the log of x to the negative 1 power. So this becomes x to the negative 1 power. And now I can take this fraction right here and multiply top and bottom by x. And this becomes x squared. This becomes 1. And this becomes x squared right down here at the bottom. So actually it works out to a pretty nice little rational function. And in fact, to begin with, you could have done the same thing. It would have been exactly the same as this, except it would have had a minus here, and you could have worked it out using the quotient rule. Okay, how about the next one? Derivative of cos of sinh of x. So let u be sinh of x. Derivative of cos u is sinh of u, that's sinh of x, times the derivative of the u. The derivative of sinh x is cos x. So it's sinh of sinh x times cos x. Alright, how about the next? The derivative of sinh square of x. That's the derivative of u square, where u is sinh x. So that's 2u to the first power. So that's 2 sinh of x. Times the derivative of the u. Derivative of sinh x is cos x. Derivative of the inverse hyperbolic what I meant was inverse, no hyperbolic. Let me just leave that one without a hyperbolic there, which is what I meant to put originally. Okay, so the derivative of inverse tangent of 3x squared. Derivative of inverse tangent of u is 1 over u squared plus 1. And then we have to multiply by the derivative of the u. The derivative of the u is 6x. I'm going to go ahead and take the 6x times the 1 is 6x in the numerator. And 3x squared is 9x to the 4th. So there's the answer. That's what that should have been. So let me go ahead and fix that problem here. I really meant for that to be just a inverse tangent of x. By the way, you know, when you're a teacher, you could do that. Oh, I don't like the problem. I think I'll just change it. Unfortunately, when you're the student, you just got to be stuck with whatever they give you. The derivative of arc sine of e to the 2x, you let u be e to the 2x, you got the derivative of arc sine of u. That's 1 over the square root of 1 minus u squared. U is e to the 2x. Then you take the derivative of the u. So this is e to the w. The derivative of e to the w is e to the w times the derivative of the w. Derivative of the 2x is, the derivative of the w is 2. And I can put the 2e to the 2x in the numerator, and e to the 2x squared, we multiply the powers here and get 1 minus e to the 4x right there. for the final answer. And another arc sine here, very similar one. The derivative of arc sine of 2x cubed minus 1 is 1 over square root of 1 minus parentheses 2x cubed minus 1 squared. So that's arc sine of u. The derivative is 1 over the square root of 1 minus u squared. And then you have to multiply by the derivative of the u. The derivative of the 2x cubed minus 1 is 6x squared. I went ahead and wrote that to the top, and I just left it like this. You could also possibly expand this out with FOIL and distribute the -1 and combine some like terms there, and there might be some other ways to write this, but actually this way of writing it is about as good as anything, so I'm going to leave it like that. So there are some, quickly went over a few more examples. Notice that some of these had things like some hyperbolic trig functions, at least some sinh and cosh in there, and some arc tangent and arc sine. So I'll give you a few more examples to look at there as well.